Hello everybody. Today I will discuss about synthetic division in theory of equation. Synthetic division to find the quotient and remainder when a polynomial is divided by binomial. Let fx is equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus an minus 1 x plus an be the polynomial of nth degree in x, and let it be divided by the binomial x minus h. Let q be the quotient and r be the remainder when fx is divided by x minus h. Then clearly q is of the form q is equal to b0 x to the power n minus 1 plus b1 x to the power n minus 2 plus b2 x to the power n minus 3 plus bn minus 2x plus bn minus 1. Therefore, we have fx is equal to binomial x minus h into quotient q plus remainder r. Thus, a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus an minus 1x plus an is equal to x minus h into b0 x to the power n minus 1 plus b1 x to the power n minus 2 plus b2 x to the power n minus 3 plus bn minus 2x plus bn minus 1 plus r. Now, equating the coefficients of like powers of x from both sides, we have a0 is equal to b0 or b0 is equal to a0. a1 is equal to b1 minus b0h, which implies that b1 is equal to a1 plus b0h. a2 is equal to b2 minus b1h, which implies that b2 is equal to a2 plus b1h. a3 is equal to b3 minus b2h, which implies b3 is equal to a3 plus b2h. an minus 1 is equal to bn minus 1 minus bn minus 2h, which implies bn minus 1 is equal to n minus 1 plus bn minus 2 into h. n is equal to r minus bn minus 1h, or remainder r is equal to n plus bn minus 1 h. The above relations give the coefficients b0, b1, b2, bn minus 1 of the quotient q and the remainder r. The above relations can be exhibited in the following manner. Here first row contains the coefficients of fx. This is h. This is first row. Coefficients of fx are a0, a1, a2, a3 up to n minus 1. Second row is obtained by here the first term in the second row is obtained by multiplying b0 by h. The first term in the second row b0h is obtained by multiplying b0 with h. So this term is b0h. b0 into h is equal to b0h. Similarly, second term is obtained by multiplying b1 with h, where b1 is equal to a1 plus b0h. The product b0h is placed under a1. Similarly, b1 into h together with a2 gives b2. b2 into h, this is together with a3 gives b3, and so on. Lastly, Rn is equal to an plus bn minus 1 h. Similarly, the term b1 is again multiply h to get b1h and added to a2 to get b2. In this repeated process, we obtain in succession all the coefficients of the quotient Q. The remainder R. Remark: when the polynomial or function fx is incomplete, that is, when any term of fx is absent, we should supply 0 in place of its coefficients while writing down the coefficients of fx. The polynomial 4x cube plus thrice plus x plus 7. Similarly, 5x to the power 5 plus 3x cube plus x plus 7 can be written as 5x to the power 5 plus 0 into x to the power 4 plus 3 into x cube plus 0 x square plus x plus 7. Now, applications of synthetic division. Example 1. Find the quotient and the remainder when the polynomial x cube plus 5x square plus 4x minus 23 is divided by x minus 3. Here h is equal to 3, a0 is equal to b0 is equal to coefficient of x cube is equal to 1, a1 is equal to 5, a2 is equal to plus 4 and a3 is equal to minus 23. The process is as follows. Multiply 1, that is b0, with h is equal to 3 and add the product to 5, that is a1. giving 5 plus 3 is equal to 8. Here 3 into 1 is equal to 3 plus 5 is equal to 8. Multiply 8, this is b1. b1 into h, this is 24, and add together with a2, this is 4 plus 24, this is 28. Sorry, this is not 48, 28. 4 plus 24, this is 28. Next, 28 is multiplied by 3 and add to the product minus 23, giving 61. So here b1 bu is 0 is equal to 1, b1 is equal to 8, b2 is equal to 28, and remainder r is equal to 61. Therefore the quotient is x square plus 8x plus 28, this is not 48 but 28, and the remainder is 61. If in the dividend any power of x are missing, their places are to be supplied by 0 coefficients. Now example 2. Divide x to the power 5 minus 2x x cube plus x minus 5 by x plus 5. Here h is equal to minus 5, a0 is equal to 1. Since x square is absent, so its coefficient is equal to 0. Also coefficient of x square is equal to 0. Therefore first row have the numbers a0 is equal to 1, a1 is equal to 0, a2 is equal to minus 2, a3 is equal to plus 0, a4 is equal to plus 1, and constant term a5 is equal to minus 5. Now in the previous process, h is multiplied by b0, this is b0h, and written down between below the 0, this gives minus 5. Minus 5 into minus 5, this is 25, which is written below minus 2, this is 25, plus 25 minus 2 gives 23. Now minus 5 into 23 gives minus 115, and together with 0 gives minus 115. Now minus 115 and h is equal to minus 5 gives 575, plus 1 gives 576. Therefore the quotient is x to the power 4 minus 5x cube plus 23x square minus 115x plus 576, and the remainder is minus 2885. we can also show that a number is root or not. Here example 3 gives that example. Show that x to the power 4 minus 5x cube minus 3x plus 15 has 5 as a root. Solution. Here h is equal to 5, a0 is equal to 1, a1 is equal to minus 5, a2 is equal to 0, a3 is equal to minus 3, a4 is equal to 15. Now a0 is equal to b0 means b0 is equal to 1, multiplying with h, which gives 5 into 1 is equal to 5. So 5 into 1, it can be written below minus 5, which gives 0. Again we have, this is b0 is equal to 1, this is b1 is equal to 0. b1 into h, this is equal to 0, which can be written below a2. So a2 plus b1 h is equal to 0. This is b2. Similarly 0 into 5 is equal to 0, together with a3 plus 0 gives b3, which is equal to minus 3. Lastly 5 into minus 3, this is minus 15, and constant term was plus 15, which gives 15 minus 15 is equal to 0. Therefore since last term is 0, which is remainder, therefore the remainder is 0. So by remainder theorem, 5 is a root. Thank you very much for watching this video, and please don't forget to subscribe my channel.